Welcome. Today's lesson is on finding the focal point or the directrix of a parabola when it's written in vertex form. So let's remind ourselves what vertex form is. Parabolas that are opened up or down will have a y equals some stretch times x minus the horizontal shift of its vertex in parentheses squared plus k, which is the vertical shift of its vertex. Or if it's opened right or left, that should be left, not down, right or left, then it will be an x equals a times in parentheses y minus k, where again k is the vertical shift of the vertex, and again squared plus h is the horizontal. So again, here we have the two examples. This is an open one that's opened up, so this would be similar to the top equation. This one here is open to the right. That'd be similar to the bottom equation. What we want to do is I want to emphasize that a parabola is curved around a focal point, what they call the focal point. And it's a certain distance away from the vertex, that lowest point, or the furthest to the left or right point of the parabola. That's the focal length. There's a line that's opposite the vertex that's exactly the same distance away from the vertex as the focal point is, that's called the directrix. The directrix will either be horizontal if the parabola is opened up or down, and the directrix is a vertical line going up and down if the parabola is open left or right. And again, it might be kind of hard to see, but there's a little f there for the focal length, is that distance from the vertex to either the focal point or to the directrix. So if you want to know what the directrix or focal point are, you first find the vertex, and written in vertex form, that's not very difficult. Then you use this simple formula. This formula down here says the focal length is found by taking 1 and dividing it by 4 times the absolute value of a. So in other words, as we look back up here at these equations, this a value, this stretch, is what affects the focal length. We take that a value, times it by 4, and then put that under 1. So it's 1 divided by 4 times a. And again, I have absolute value bars because we just want its absolute value. The focal length is always a positive number. And then when you find the focal point, if it's opened to the right, you would add the focal length to the x value of the vertex, and the y value would stay the same. If you were to find the directrix, you would minus the focal length from the x value, and then you would just say x equals. This is, see, plus or minus the focal length, depending on whether the directrix is on the left side or the right side of the parabola, whether it's open left or right. Same thing here. The directrix is going to be just your k value, your y value of your vertex of that point. You either add or subtract the focal length going up to the focal point or down to the line of directrix, which if it's opened up, it's a horizontal line. So let's do an example. Okay, so let's say you're given this equation. Y equals 3 parentheses x plus 2 squared minus 7. Okay, and you're asked to find the focal point and the directrix. Well, the first thing I'm going to do is off to the side, I'm going to write down the vertex. What is the vertex? Well, this is in vertex form. The vertex is -2, because this parentheses has an x inside. -2 plus 2 is 0. So the vertex is at -2, -7. So now I found my vertex. The next thing I'm going to do is, does this parabola open up or down? It's opened up because 3 is positive. So I'm going to write over here that it's opened up. So I might even do a little diagram, put a focal point here and a directrix underneath. That's what it's going to look like. A parabola with a focal point inside of it and a directrix below it, where this point right here is a -2, -7. Now what I need to do is I need to find this focal length. Now remember, the focal length is found by taking 1 and dividing it by 4 times the absolute value of A. A is 3. So I'm going to do 4 times 3. Or the focal length is 1/12. And yes, oftentimes the focal length will be a fraction or a very small number. This focal length is what I'm going to add now to the y value to find its focal point, and I'm going to minus it from the y value to find its directrix. So the focal point would be a -2, because I'm not to the left or right of the vertex. I'm just going to be shifted up. And then I'm going to take -7 and I'm going to add 1/12 to it. So I would end up getting, and I'm going to try to make this simple. Let's see, 7 times 12 is 70, 84. So -7 is -84/12. That's 7. Whoops, sorry, you can't quite see that. -84/12 is this -7 of the vertex. I'm going to add 1/12 to that. So my focal point will be a -83/12. There's my focal point. If I wanted to find my directrix is a horizontal line. I would do y equals, because it's a horizontal line, and it's just the y value, but now I'm going to minus 1/12. So instead of -84/12, which is the vertex, I'm going to do a -85/12. There's the directrix. So I just found the focal length and added it and subtracted it to the y value because it was opened up or down. Let's do one more. Let's do this one. X equals -1/12 parentheses y minus 3 squared plus 8. Now again, first thing I'm going to do is I'm going to find the vertex and tell me if it's opened up, down, left, or right. Well, since x is not squared, the y is squared, I know this one's going to be open right or left. And since this value in front of the parentheses is negative, it's open left. So it's open left. And the vertex, now be careful here, the y value of my vertex is 3, and the x value of my vertex is 8. So I found my vertex. Now again, I just like to draw a quick little thing. My vertex is over 8, up 3, and I'm opened left. I open like this. That means my focal point will be somewhere over here, and my directrix will be to the right of that. Now I need to find that focal length. Remember, the focal length is equal to 1 divided by 4 times the absolute value of this number. Now again, a lot of times this stretch is a small fraction, and you need to be able to do your fractions. Now I'm doing positive 1/12 because we take its absolute value. What's 4 times 1/12? Well, that's going to be 1/3. And then what's 1 divided by 1/3? That's 3. So my focal length is 3. That means I'm going to move 3 units that direction and 3 units that direction to find the focal point and the directrix. Since my vertex was 8, 3, and I'm moving to the left, that's going to change the x value. And to find the focal point, I will minus 3 from 8. So my focal point is going to be 8 minus the focal length, which is 3, so I get 5. The y value, it's not up or down, it's just directly left of the focal, so it's 3. There's my focal point. My directrix is going to be a vertical line, so it's going to be x equals some number. Now, again, it's going to be this x value, but now I'm going to, since it's to the right, I'm going to add the focal length. Focal length is 3, so I'm going to add 3 to 8 and get 11. And so there's the equation of my directrix, and there's the equation of my focal point. Hopefully you're able to follow that. If you have any questions, please bring them to class.